All right, today we're diving into one of the coolest tricks in the entire AI world, data augmentation. Seriously, this is a technique that lets you get so much more out of the data you already have. It's how we make our models smarter, tougher, and way more reliable. So let's get into it and see how we can teach our AI to see more than what's literally in front of it.
I mean, just think about that for a second. What if you could take the dataset you have right now and spin it into 1,000 different versions, 1,000 new examples for your model to learn from? And get this, without having to go out and collect a single new photo, a single new sentence. That's the big promise here. And let's be real, in a world where AI models are starving for data, this isn't just some nice-to-have trick. It's a lifesaver.
Okay, so why is this such a big deal? Well, you've probably heard that deep learning models are data hungry, right? They need to see a ton of different examples to actually learn something useful. If you don't give them enough variety, they just get stuck. They can't handle anything they haven't seen before. And that, right there, is the huge data problem we're always fighting in AI.
And this lack of variety leads to this really nasty problem called overfitting. You've got to watch out for this one. It's basically when the model doesn't learn, it just memorizes. It's like it's cheating on the test. It gets a perfect score on the training data, but the second you show it something new from the real world, it completely freaks out. The student-driver analogy is perfect. They know that one test route perfectly, but ask them to make a left turn on a street they've never seen? Total disaster.
So that brings us to the big question, right? We know we need more data, more variety. But going out and collecting and labeling thousands or even millions of new images or texts, I mean, that's crazy expensive and takes forever. So how do we get around that? How do we give our models the rich diet they need without breaking the bank? Yep, you guessed it. This is where data augmentation comes in to save the day.
All right, let's start with the easiest place to see this in action, images. It's super visual, super intuitive. We're going to take a single picture and, like magic, create a whole bunch of new, slightly tweaked versions of it. And the crazy part is, each one of these new images is just as good for training our model as the original.
First up, one of the simplest, but honestly one of the most powerful tricks in the book, a simple horizontal flip. All we're doing is mirroring the image. But think about what this teaches the model. It's a really basic but crucial rule. A cat is a cat. Doesn't matter if it's looking left or looking right. We humans get that instantly, right? But a computer has to be taught that explicitly.
Okay, next up is rotation. Because let's face it, in the real world, things are rarely perfectly aligned with your camera. You're not always going to see a stop sign perfectly straight on. It's going to be tilted, you're going to see it from an angle. By feeding our model all these slightly rotated versions, we're making it tough enough to handle the messiness of reality. And then there's random cropping. This is huge for tackling a problem you see all the time, called occlusion. That's just a fancy word for when something is partially blocked or cut off by the edge of the picture. By showing the model just a piece of the car, it has no choice but to learn to recognize it from, say, just the headlights and the grille. It can't get lazy and rely on seeing the whole thing every time.
Last but not least for images, let's talk about color. Think about taking a picture on a super sunny day versus in a dark, moody room. The colors look totally different, right? Well, that's what we're simulating here with something called color jitter. We just randomly mess with the brightness, the contrast, the saturation. This forces the model to stop paying so much attention to the exact colors and instead focus on what really matters: the shape, the form, the texture of the object.
Now, this whole idea isn't just for pictures. It goes way beyond pixels. I mean, obviously, you can't just flip a sentence backwards and expect it to make sense. But don't worry, people have come up with some equally clever tricks for working with text and even audio.
So let's take a look at text. Here's our starting sentence, nice and clear. This article will focus on summarizing data augmentation techniques in NLP. Okay, so how do we mix this up without changing what it actually means?
Well, one of the easiest ways is just synonym replacement. Check it out. We swapped article for write-up and techniques for methods. The meaning is exactly the same, we all know that. But for a machine learning model, this is a completely new sentence, a whole new data point to learn from. It's so simple, but it works so well.
And it gets even more creative. There's this really cool hack called back translation. You take your English sentence, run it through a translator to, say, Spanish, and then translate it right back to English. You often get a slightly different sentence that means the same thing, a perfect paraphrase. Or you can just randomly delete a few words. That sounds a little destructive, but it actually forces the model to get way better at figuring out the meaning from the context of the words that are left.
And you can do the same thing for audio. I mean, think about trying to use a voice assistant in a crowded coffee shop or on a busy street. It's tough, right?
So what we do is take clean audio recordings and we artificially add in that background noise, people talking, cars honking, all that stuff. This trains the model to be a much better listener and to pick your voice out from all that chaos in the real world.
Okay, so we've seen all these cool tricks, but how does this actually work in practice? I mean, you're not sitting there manually flipping and saving thousands of different images, right? No, no, no. The way it's done today is way, way smarter.
It's all about something called on-the-fly augmentation. And what that means is we don't create a giant folder of all these new images beforehand. That would be a storage nightmare. Instead, we do it in real time, as the model is training. So every single time the model looks at an image, we apply a random little change. Maybe this time it gets flipped. The next time it sees that same image, maybe it's slightly rotated and the colors are tweaked. This is amazing because it saves a ton of disk space, and more importantly, it means the model almost never sees the exact same image twice. It's like having an infinite data set.
And you know what the best part is? You don't have to code any of this crazy stuff from scratch. The open source community has our backs with some amazing libraries. For images, tools like Augmentations and Imagog are super popular because they're fast and have tons of options. If you're working with text, NLPaug is fantastic. And of course, the big players like PyTorch and TensorFlow have all these capabilities built right into their core frameworks. So it's really easy to get started.
Okay, theory is one thing. All these tricks sound great on paper, but what's the bottom line? Does this whole process of creating fake data actually make our models better? Does it really move the needle on performance? Well, let's look at the proof.
And here it is. This is the moment that should convince you. This chart is just wow. Look at the bar on the left. That's a model trained on 100% of the available data. It hits about 87.4% accuracy. Not bad. But now look at the bar on the right. That model was trained with data augmentation, but on only half of the original data. And its accuracy is higher, 88.3%. I'm going to say that again. It got a better result with half the data. That is just incredible.
That one number really says it all, doesn't it? 50%. That means you could potentially slash your data collection and labeling budget in half, and not only match the performance of the full data set, but actually beat it. For any project, any company that's struggling to get enough data, this is an absolute game changer, period.
And I really want to stress, this isn't just some clever hack for people who don't have enough data. This is standard operating procedure. This is how the pros build the best models in the world. Let's take a look at some of the big names.
Just take a look at this. We're talking about legendary models here. AlexNet, one of the originals, used it. ResNet, a total workhorse, uses it. And then you look at something modern and powerful like YOLO v4, and wow, look at that list. They're using a whole kitchen sink of augmentation techniques. This shows you it's not just a nice little add-on, it is a core, fundamental part of how you get to state-of-the-art results. So, if you want to use this yourself, how do you do it right? Here are a few pro tips. First, you've really got to know your data. For example, don't horizontally flip images of the number 6 and expect it to work for the number 9, right? Second, start simple. Flips and crops are your best friends. Don't go crazy right away. Third, be careful not to go overboard. If you augment an image so much that even a human can't tell what it is anymore, you've gone too far. And last, and this is maybe the most important rule of all, always split your data into your training and testing sets before you do any augmentation. If you don't, you'll end up with leaky data, and your model's performance will look way better than it actually is. It's like letting the student peek at the exam answers beforehand.
When you really boil it down, data augmentation is all about teaching machines a little bit of common sense. You know, things we take for granted. That a cat is still a cat if it's in the shade, or if you're looking at it from the side. It's a massive shortcut to help them generalize to the real world. And that leaves us with a pretty big, exciting question to think about. If we can teach an AI to see 1,000 different possibilities in just one picture, what other human learning shortcuts, what other bits of common sense can we bake into our models next? It's a fascinating thing to consider. Thanks for joining me.